Hello everyone, welcome back to my YouTube channel. I am Ishwardhan, currently pursuing my education in Sri Venkateswara College of Engineering of Department CSE Cyber Security. In this video, we are going to discuss about pointers in data structures. Introduction to pointers. Pointers in programming languages like C and C++ stores memory addresses. They allow you to directly manipulate memory, enhancing efficiency and flexibility in managing the data structures. Pointers are variables that stores memory addresses. They allow direct manipulation of memory locations. Pointers are a fundamental concept in programming. Introduction to pointers. Pointers is the address that is a specific memory location of an object. It can refer to different objects at different times. Pointers are used in C programming for a variety of purposes to return more than one value from function using pass by reference to create and process strings, to manipulate the contents of arrays and structures, to construct data structures whose size can grow or shrink dynamically. Declaration and initialization of pointers. Pointers are declared by using the asterisk symbol before the variable name. They must be initialized with the address of a variable. The general syntax for declaring a pointer variable is data type followed by pointer name. Here, the data type refers to the type of the value that the pointer will point to. Here is a simple example: int star ptr equals ampersand x holds the value 5, and the address of the variable 5 is 1000. Ptr holds the address of the variable x, that is 1000. Accessing the value of a pointer. The value of a pointer can be accessed by using the asterisk symbol before the pointer name. In example, int x equals 10. Accessing a variable through its pointer. Once a pointer has been assigned to the address of a variable, the value of variable can be accessed using in direction operator. Int a comma b, int star p semicolon, p equals ampersand a, b equals star p, which equals b equals a. Next is pointers and memory management. Pointers allow dynamic memory allocation. They can be used to allocate memory for arrays, structures, and other data types. Memory allocated using pointers should be properly deallocated to avoid memory leaks. Dynamic memory allocation. Programmers use dynamic memory allocators such as malloc, calloc, realloc, and free to acquire virtual machine at runtime. For data structures whose size is only known at runtime, dynamic memory allocators manage an area process virtual memory known as heap. Pointer arithmetic. Pointers can be incremented and decremented. Incrementing a pointer moves it to the next memory allocation of the same data type. Example, ptr plus plus, where ptr is the pointer of an integer variable. Here is a simple program for the example of pointer arithmetic. Next is null pointer. Null pointers have a value 0 or null. They are used to indicate that the pointer does not point to a valid memory location. Null pointer should be checked before dereferencing to avoid crashes. Next is pointers and function calls. Pointers can be passed as parameters to the functions. They allow functions to modify variables outside the scope. Example, void change value of int. In function calls, pointers can be used to pass memory addresses instead of actual data. This enables functions to modify values at those addresses directly. This can be moved more efficient than passing large data structures, as it avoids unnecessary copying. Pointers in function parameters allows for in-place modification, enhancing the flexibility of function behavior. Pointers and arrays. Pointers and arrays are closely related. An array can be treated as a pointer to the first element of the array. Example, int array of 5 equals, and an array name often represents a pointer to the first element of the array. You can use pointers to iterate through array elements, dynamically allocate memory for arrays, and pass arrays to functions efficiently by passing their memory addresses. Understanding the relationship between pointers and arrays is fundamental for efficient memory manipulation and array handling in these languages. Next is pointers and strings. Strings in C are represented as array of characters. Pointers can be used to manipulate and iterate through strings. Pointers play a crucial role in string manipulation. A pointer to the first character of a string can be used to access and manipulate the entire string. Functions like strcpy, strlen, and strcat rely on pointers for string operations. Pointers make it possible to pass strings to functions efficiently by passing the memory address of the string's first character. Understanding pointers is essential for effective string handling. Next is pointers to pointers. Pointers can also have pointers as their values. They are called pointers to pointers or double pointers. They are useful for dynamic allocation and multi-level data structures. The variables that the memory address of another variable it stores the memory address of another variable. They are useful in scenarios where you need to modify the value of a pointer itself, not just the value it points to. This is common in dynamic memory allocation and dealing with arrays of pointers. In C, you might have encountered the pointers where when working with functions that allocate memory dynamically or modify pointer variables directly. Common mistakes and pitfalls. Dangling pointers. Pointers that points to invalid memory allocations. Memory leaks. Forgetting to allocate dynamically allocated memory. Null pointer dereference. Accessing the value of null pointer. Dangling pointers. A dangling pointer is a non-null pointer that points to the unallocated memory. Dereferencing a dangling pointer may cause program to crash. It is impossible to test a pointer to see if it is dangling. Always set pointer to null if they do not print to allocated memory. Dangling pointer must always be avoided. Summary and conclusion. Pointers are powerful tools for memory manipulation in programming. They allows direct access and modification of memory locations. Understanding pointers is essential for efficient and advanced programming. Thank you.